Hello everyone, welcome to this class. Today we are going to discuss about the Kepler's law from the Gravitation's class 11 physics. And in gravitations, the most important topic is our universal law of gravitations. Or before going to discuss about the universal law of gravitations, we have to discuss about the Kepler's law because your universal law of gravitation is based on the Kepler's law, and Kepler's law of planetary motions is about the three different law. First law is about its orbit, second law is about its area, third law is about its time. Okay, planetary motions, if we discuss, then generally Copernicus gives a statement that all the planets are moved in a circular orbit and Sun is at the center. But after some times, Kepler's prove it wrong and he modified it that the circular path is your elliptical path. The meaning is that all the planets are moving around the sun but in an elliptical path, and sun is one of the focus, or sun is at the position of the focus. That means we know that in an ellipse two focus are there, two foci points are there, and sun is placed at one of the focus, and all the planets are moving in the orbit, elliptical orbit. So according to Kepler's law, Kepler's give the three statements, three law. First law states that according to Kepler's first law, law of orbit, this one is about the orbit of the planets. That's why this is also known as the law of orbit. And according to the first law, the orbit of the every planet is an ellipse and around the sun, which with sun at one of the two foci of the ellipse. If we will discuss a elliptical shape here, then this one is the ellipse, O is the center, F1 and F2 are the two focus, and here two axes are there. One is the major axis, another one is the minor axis, and your if we will discuss it here, then OA is the your semi major axis and OB is the semi minor axis, and in the major axis two points F1 and F2 are the point at which sun is placed. That means if we assume that this one is the position of the sun, then sun is the here at focus F1, and the planet are moving in this elliptical orbit around the sun. This one is the first law of orbits. Next is the law of area or second law of Kepler's. According to Kepler's second law, the line joining a planet to the sun sweeps out equal area in equal interval of time. The meaning is that if this one is the position of sun and this one is the position of planet, in this elliptical orbit, if the planet moves or it creates lines joining the sun, let take here this one is the sun positions and here this one is the planet at P1 positions. This one is sun and this one is the P1 positions. After some times the planet will be here in another point P2. Then this is the area coverage with respect to the sun. So this area in a particular time, let's take del t is the time. Del t is the time taken for this particular area. Then sweeps out equal area in equal interval of times. Similarly, if we are going to observe the same planet in another 2 points, let's take here P3 and another point is your P4. So If we will trace it like this, then this is the area coverage. Now, in the same times delta t, if the planet moves from P1 to P2 or P3 to P4, then the area coverage is also equal. So, according to the second law or law of area, it states that delta A by delta T must be constant. What do you mean by delta A? That means small change in area or your area cover in delta T times. It must be constant at every point. So, according to the second law, this one is your law of area, or it cover equal area in equal interval of time. Next is our third law. Third law of planetary motions of Kepler's law is our law of period. According to the Kepler's third law, it states that the square of the time period of a planet is directly proportional to the cube of the semi-major axis. If we will discuss about a ellipse, then this one is the major axis and this one is minor axis. So OA is the semi-major axis and OB is the semi-minor axis. So let's take OA is OA. OA is your A and OB is your B. That means the semi-major axis is taken as small a and semi-minor axis is taken as small b. So, time period means what? The planet required how much time to move complete orbit around the sun, or how much time is required to complete the full orbit. That is the time period. So, square of this time period is proportional to the cube of the semi-major axis. That means OA. So, according to the law of period, it states that the time period is related to the major axis h t square is proportional to a cube. So, this one is about the Kepler's law, and from the Kepler's law or based on this Kepler law, Newton derived the universal law of motion.